In this video, we'll talk about the second part of this chapter, which is chemical quantities. So to begin with that, the first concept of this chapter is the concept of moles. So what is a mole? Just how usually when we are talking about number of eggs or bananas, we count, instead of saying that we have 12 bananas or 12 eggs, we usually say we have a dozen eggs. When we talk about sheets of paper, we usually say 500 sheets is equal to 1 ream of paper. Similarly, when you see a can of Coke or soda, we basically usually say that 24 cans is 1 case. That basically helps us to reduce the number of quantities of the atom that we are working with, right? This is just a term that has been used to replace the actual number of items. A similar quantity that is used in chemistry is called mole. 1 mole in chemistry is equal to 6.02 times 10 raised to power 23, which means if I say we have 1 mole of carbon, that means I'm saying 1 mole of carbon is 6.02 times 10 raised to power 23 atoms of carbon. So 1 mole of anything in chemistry is equal to 6.02 times 10 raised to power 23 particles. That can be atoms or it can be molecules, whatever we are talking about. This number right here is called Avogadro's number. 1 mole of any chemical compound consists of 6.02 times 10 raised to power 23 particles, atoms, or molecules. You need to memorize this number. Just make sure 1 mole is just a unit defined as Avogadro's number. So basically you could say 1 mole is these many particles. Particles can be in terms of atoms, molecules, or ions, and this can be used as a conversion factor as well. And that, for instance, the number of atoms that are present in 2 moles of aluminum is, the question is asking how many atoms are present in 2 moles of aluminum. So when we say 2 moles of aluminum, the conversion factor to go between moles and number of atoms is 1 mole of aluminum is 6.02 times 10 raised to power 23 aluminum atoms. So this is our conversion factor. What is given to us? The starting unit we have is 2.0 moles. We are going from moles to number of atoms, and the conversion factor to go between that is this. So we start with what's given, which is 2.0 moles of aluminum. Now to cancel moles of aluminum, I will divide by moles of aluminum. This is just like dimensional analysis. The other side of conversion factor is atoms of aluminum, so we'll write aluminum atoms and now plug in the numbers. Mole was 1, atom is 6.02 times 10 raised to power 23. Moles and moles got cancelled. The final answer is in number of atoms of aluminum. So now if you plug in this value into your calculator, that would give you 12.02 times 10 raised to power 23 aluminum atoms, which can also be written as, I need to shift this decimal by 1 place, so that would make it 1.202 times 10 raised to power 24 aluminum atoms. And since this initial number is 2 sig figs, my final answer should be 2 sig figs of 1 and 2, which means 1.2 times 10 raised to power 24 aluminum atoms. So that would be our final answer for this question. Okay, the other question the number of moles. The other type of question you can expect is the number of moles of sulfur in these many atoms of sulfur is. Question, what is given to us? The question is giving us number of atoms of sulfur, and it's asking how many moles is that. So what's given to us is atoms. The question is asking to go from atoms to moles. Do we know a conversion factor that relate moles and atoms? 1 mole of anything, in this case it is sulfur, is 6.02 times 10 raised to power 23 atoms of sulfur. So we'll use this conversion factor. How many atoms are given to us in question? Always write what's given to you first, which is 1.8 times 10 raised to power 23 atoms of sulfur. Now to cancel the atoms, I'll divide by atoms of sulfur, multiply by moles of sulfur. 1 mole of sulfur is 6.02 times 10 raised to power 23 atoms. Atom got cancelled. Our final answer is in moles of sulfur. If you plug this into your calculator, it would give you 3.0 moles of sulfur. So our final answer is number B. Moving on, we'll continue with the concept of moles. Just how in previous topics we saw that moles can be written as 1 mole of a substance. 1 mole of sulfur or copper or aluminum is equal to 6.02 times 10 raised to power 23 atoms. 1 mole can also be used to describe, instead of using one element, we can use the compound. So by compound, we need the chemical formula. So you know, when we say a compound has this chemical formula C9H8O4, that means it consists of 9 atoms of carbon. 1 atom of C9H8O4 consists of 9 atoms of carbon, 8 atoms of hydrogen, and 4 atoms of oxygen, right? This is when we say 1 atom consists of this. 1 molecule, sorry, not atom. 1 molecule, because this is a molecule now. 1 molecule of C9H8O4 consists of these many atoms of carbon, hydrogen, and oxygen. Similarly, we can say that 1 mole of C9H8O4 consists of 9 moles of carbon, 8 moles of hydrogen, and 4 moles of oxygen. So number of atoms in a molecule is same as number of moles of that atom in 1 mole of that molecule. Okay. And what is this? This symbol that you're seeing here is called a compound chemical formula. And each subscript that you see tells us how many number of atoms are present in that particular compound. Okay, so we can use this also as a conversion factor. For instance, 1 mole of C9H8O4 consists of 9 moles of carbon. So we can use this as a conversion factor. 1 mole of C9H8O4 is 9 moles of carbon. Okay, so this is your conversion factor if you want to figure out how many moles of any element are present in this molecule. For instance, a question like this: how many atoms of oxygen are present in 0.15 mole of aspirin? The question is asking, what's given to us is moles of aspirin. The question is asking how many atoms of oxygen are present in there. What would be first conversion factor that we see? First, we'll go from 1 mole of aspirin consists of 4 moles of oxygen. This is our first conversion factor, which will help us to convert from, we cannot directly go from moles to atoms. We will convert moles of aspirin to moles of oxygen first, and then once we know moles of oxygen, we can go from moles of oxygen to atoms of oxygen, because we know that 1 mole of oxygen consists of 1 mole of, number of atoms is 6.02, oh, 6.02 times 10 raised to power 23 atoms of oxygen. So we'll start with what's given, which is 0.150 moles of aspirin. To cancel moles, I divide by mole of aspirin and multiply by mole of oxygen. 1 mole of aspirin is 4 mole of oxygen, like we see here. Now my answer is in moles of oxygen. So I have reached this spot right here. Now we go from moles of oxygen to atoms. To cancel mole, I divide by moles of oxygen, multiply by atoms of oxygen. 1 mole of oxygen has 6.02 times 10 raised to power 23 atoms. Moles and mole was cancelled. Your final answer is in number of atoms of oxygen. Plug this into your calculator. It would give you 3.612 times 10 raised to power 23 atoms of oxygen. And how many sig figs are we looking for? The only relevant sig fig here is coming from 0.150. This is an exact number. This is also exact, so we don't care about sig figs. We'll go from here. This is 3 sig figs, so we want final answer to have 1, 2, 3 sig figs, which is 3.612 times 10 raised to power 23 atoms of oxygen. Okay, moving on. Next concept we'll talk about is molar mass. What is molar mass of an element? If you guys remember, we talked about this in the chapter of atoms and elements. In periodic table, you will see with each element, one number is written on top, which is called the atomic number. This tells you how many number of atoms are present in something. Protons are present in an atom. Whereas the number at the bottom tells you what is the mass of atom. So, or the mass of the element. So this basically means when we say, based on this number, we can say that 1 mole of sodium will weigh 22.99 grams of sodium. Okay, so by looking at this, you can say that what is the weight of 1 mole of a substance, 1 mole of an element, but just by looking at periodic table. So from periodic table, you can say that 1 mole of sodium will weigh 22.99 grams. Okay, and this is now a new conversion factor that will help you to go between moles to grams. And the number that you see on the bottom is referred to as, since this is mass of 1 mole of a substance, it is also called as the molar mass of that particular element. Molar mass means mass of 1 mole of that element in grams. So molar mass of an element is the mass of 1 mole of a element, and this is basically used as a conversion factor. Like if you write it in this form, you can use it as a conversion factor. Okay, for instance, if you look at periodic table, you look at the number in the bottom, it will tell you that 1 mole of carbon weighs 12.01 grams. 1 mole of silver weighs 107.9 grams. 1 mole of sulfur weighs 32.07 grams. Okay, so each element you just have to look at the periodic table. So molar mass is the mass in grams of 1 mole of a substance. This is when we are talking about element. For instance, when we talk about moles, if I say a substance like hydrogen, if you look in the periodic table, 1 mole of that would weigh 1.008 grams. And another concept that we know now is that 1 mole of any element will consist of Avogadro number of atoms. So now you can relate the number of atoms to grams. Okay. For instance, 1 mole of calcium will always consist of 6.022 times 10 raised to power 23 atom, and that would weigh around 40.08 grams. So what is the weight of one atom of calcium? One atom of calcium would essentially weigh 40.08 grams over 6.022 times 10 raised to power 23. So this would be grams per atom. So meaning one weight of one atom in grams. Alright. So that is how you can relate molar mass to number of atoms, or molar mass to number of moles of a substance or an element. For instance, let's try this question. Calculate the moles of sulfur in 57.8 grams of sulfur. So here the question is asking, what's given to us is grams of sulfur, and it's asking what is the moles of sulfur. So we need to basically go from what's given to us as gram, which is 57.8 grams, and what do we need to find is moles of sulfur. So what is our solution map? We need to go from sulfur grams to moles. Do we have a conversion factor that directly relates grams and moles of a substance? Yes. 1 mole of a substance is always its molar mass, which you can get from periodic table. So if you look at your periodic table, 1 mole of sulfur will weigh around 32.01 grams of sulfur. Okay, so this is our conversion factor that will help us convert between these two units. So we start with what's given to us, which is 57.8 grams of sulfur. Now we want to cancel these grams of sulfur, so we'll divide by grams of sulfur. What's the other conversion unit? It's moles of sulfur. So 1 mole of sulfur is 32.01 grams. Grams and grams got cancelled. Your final answer is in moles. If you plug this into your calculator, that would give you 1.80 moles of sulfur. Again, the question gives us how many sig figs right here? 1, 2, 3. So this is 3 sig figs, and we want final answer to be 3 sig figs as well. Okay, moving on, what else? What other question could you look like from the same concept? Something like this. How many copper atoms are in a penny weighing 3.180 grams? So what is the question asking? The question is asking what's given to us. Let's figure that out first. The question is given us that we have 3.10 grams of copper, and it's asking to go from grams of copper to number of atoms of copper. Do we have a direct relationship? So basically we have to go from grams of copper, let's make our solution map, to number of atoms of copper. Do we have a direct conversion factor that relates grams to number of atoms? No. We have a conversion factor that's in the middle, which will help us go from grams of copper to moles of copper, and then from moles of copper we can go to atoms of copper. So that would be your scheme in this case. So how can we go from grams to moles? We know that 1 mole of copper, if you look at your periodic table, is equal to 63.55 grams of copper. So that is our conversion factor. Where did I get this number from? 63.55, again from periodic table. And now we need to go from moles to atoms. So we know that 1 mole of anything, which in this case is copper, is 6.02 times 10 raised to power 23 atoms. So you can basically use this conversion factor to go from one to the other. Let's start with what's given, which is 3.10 grams of copper. To cancel grams, I divide by grams, multiply by mole of copper. How many moles? 1 mole is 63.55 grams. Grams and grams got cancelled. My final answer here is in moles of copper. So I've reached this step now. Now I need to go from moles of copper to atoms of copper. To do that, I use this conversion factor. So to cancel moles, I divide by moles of copper and multiply by number of atoms of copper. Moles is 1, atoms is 6.02 times 10 raised to power 23. I'm just plugging in the numbers that you see in front of these units. Now moles of copper and moles are cancelled. Our final answer is in number of atoms of copper. If you plug this into your calculator, it will give you 2.94 times 10 raised to power for copper atoms. 10 raised to power 22 atoms of copper. And what number of sig figs we are looking for here is 3. What's given to us in question, and our final answer is also in 3 sig figs. So that would be our final answer for this question. Basically, you should know these conversion factors, that 1 mole of any substance is going to be equal to molar mass of that substance. And we know that 1 mole of a substance consists of 6.02 times 10 raised to power 23 atoms or molecules or ions or particles. Okay, so these are the two conversion factors that relates moles to number of atoms or molecules and moles to molar mass in grams. Okay. The solutions provided to you in this slide as well. Okay, next we will come to molar mass of compounds. Just how we saw right now, we were working with elements. 1 mole of an element is molar mass of an element from periodic table. Similarly, this concept of moles and molar mass can be applied to compounds. What does that mean? When we talk about compounds, we can calculate the molar mass of a compound as well. For instance, if I say 1 mole of hydrogen, water, which is also like hydrogen hydroxide if you want to call it that, but basically if we say 1 mole of water will consist of what? We know from the subscript it consists of 2 moles of hydrogen and 1 mole of oxygen. So what is the mass of 1 mole of water? That would be mass of 2 moles of hydrogen plus 1 mole of oxygen, and that mass is called the molar mass of water. So basically 1 mole of water would weigh how much? It would weigh equal to the molar mass of water in grams. And how can we find molar mass? Basically each water consists of 2 atoms of hydrogen, so it would be, and each atom from periodic table weighs 1.01 grams. So 2 atoms will weigh twice of that, so 2 times 1.01 plus we have 1 atom of oxygen, so it will be 1 times 1 atom from periodic table is 16.00 grams of oxygen. If you sum this up, if you add it all together, that would give you 18.02 grams of H2O. So we have new conversion factor for every compound. We can say that 1 mole of that compound is equal to molar mass of that compound. So 1 mole of water is 18.02 grams of water. So there's your new conversion factor now. You can do this for any compound. As long as you can calculate the molar mass of that compound, you can go from moles of that compound to grams by using this conversion factor. And how do we find weight of that? You use the numbers from periodic table and the subscripts in the chemical formula. Okay. If we were to do this question, calculate the molar mass of lithium carbonate. Lithium carbonate is Li2CO3. So how do we find the molar mass of that? What does lithium carbonate consist of? It basically consists of 2 atoms of lithium and 1 atom of carbon and 3 atoms of oxygen, or 2 moles of lithium, 1 mole of carbon, or 3 moles of oxygen. So if we can find the mass of each one of these, we add it up together and that would give us the molar mass of lithium carbonate. So what is the mass of 1 atom of lithium? You will look for your periodic table right here, this number. Always go for 2 sig figs. Okay, So 2 atoms of lithium would weigh 2 times 6.94 grams of lithium. Next we have 1 atom of carbon. Carbon is right here. You can see the number is 1 atom of carbon weighs 12.01 grams. We'll add that up. And lastly we have 3 atoms of oxygen. 1 atom weighs around 16.00. If you round it up to like 2 decimal places, always round up the number to 2 decimal places from your periodic table. And we have 3 atoms, so 3 times 16.00 grams of oxygen. You add it all together and that would give you the final molar mass of lithium chloride. Now remember, when you're plugging all of this into calculator, just make sure you include the parentheses as well. If you do 2 times this, put a parentheses and then calculate. That would give you a final mass of 79 point something that you saw on that particular slide. Okay. Next example you see right here. What is the molar mass of CH4? Methane. Again, this consists of 1 atom of carbon. So it would be, a mass of carbon would be essentially 1 times 12.01 grams from periodic table. And it consists of hydrogen. How many? 4. So 4 would weigh 4 times 1.01 grams of hydrogen. You add this together and this would give you molar mass of 16.05 grams of CH4. So that is the molar mass of CH4, meaning we can use this conversion factor. 1 mole of CH4 is equal to 16.05 grams of CH4. Now you can use this conversion factor as needed. This is a conversion factor to go between moles to grams of a compound. Again, between moles and grams, it's always 1 mole of any substance is equal to molar mass of that substance in grams. This could be a compound, an element, or an atom. What kind of questions you could see? Something like this. A box of table salt, NaCl, this table salt, contains 737 grams of NaCl. How many moles of NaCl are in the box? So what is given to us? We are given to us grams of NaCl. The question is asking to go from grams to moles. So what's given to us? Let's make our map. Grams of NaCl. We need to go from grams of NaCl to moles of NaCl. What is the relationship that relates moles to grams? It is molar mass. So let's find molar mass of NaCl first. NaCl consists of 1 atom of Na. So Na would weigh 1 atom of Na from periodic table is 22.9 grams. And 1 atom of chlorine from periodic table is 35.45 grams. Now if you add this up together, that would give you 1 molecule of NaCl. So basically 1 mole of NaCl based on this would weigh around 58.44 grams of NaCl. So that is our molar mass of NaCl. So what is our conversion factor? Our conversion factor is essentially 1 mole of NaCl is 58.44 grams of NaCl. So from here we can go between grams and moles. So we start with what's given, which is grams, which is 737 grams of NaCl. To cancel the grams, I divide by grams of NaCl and multiply by moles of NaCl. How many moles? 1 mole. How many grams? 58.44 grams. So grams and grams got cancelled. Our final answer is in moles, which will give you, if you plug this into your calculator, 737 divided by 58.44, that would give you around 12.61 moles of NaCl. How many sig figs are we looking for? 1, 2, 3. So our final answer would be 12.6 moles of NaCl with 3 sig figs. Okay. The next question says calculate the number of grams in 0.5 moles of NaCl. So now what's given to us is moles, and the question is asking us to go from moles to grams. Again, what is the conversion factor between moles and grams? 1 mole of anything, in this case NaCl, will weigh its molar mass. We just calculated that was 58.44 grams of NaCl. Now you start with what's given, which is moles. So it is 0.500 moles. I want to cancel the moles, so I divide by moles of NaCl and multiply by the other side, which is grams of NaCl. Plug in the number. Mole is 1, grams is 58.44 grams. Moles and moles got cancelled. Our answer is in grams of NaCl. So if you basically now just plug these numbers into calculator, 58.44 times 0.5 will give you 29.22 grams of NaCl. How many sig figs are we looking for? The question has 1, 2, 3 sig figs. So we want our final answer to have 3 sig figs. So our final answer would be 29.2 grams of NaCl. So that is how you can go between moles and grams of an element or a substance. Similarly, you can introduce atoms here, and now you know the conversion factor between moles and atoms as well. So if needed, you can use that conversion factor as well. Okay, so here's like one kind of solution map that is given to you. If grams of an element are given to you, you can go from grams to moles by using molar mass, and from moles you can go to number of atoms by using Avogadro's number. Similarly, if a compound is given to you, grams are given, you can go from grams to moles by using molar mass, and from moles to number of molecules by using Avogadro's number. You could also do reverse. If number of molecules is given to you, we can convert that into moles by using Avogadro number, and then from moles we can go to molar mass, grams by using molar mass. Only important thing is, remember, the midpoint will always be moles. You have to figure out moles to figure out any of the other components. Okay, so in chemistry, what's the most important thing, or the most important unit of an amount of a substance is moles. Okay, all right. So let's talk about another concept, which is called stoichiometry. So you know that a lot of these chemical reactions, why are they important for us? Because we can perform these chemical reactions in an industry to produce certain amount of products, right? But in industry, we always want to use the produce the maximum amount of products by using the least amount of reactant. So we want the least wastage, right? So we need to know how much exact amount of reactants should we mix to get a certain amount of product, right? So if we can quantify that, that would be very helpful. And how can we quantify that? That can be quantified by use of a balanced chemical reaction and the concepts of stoichiometry. Metry essentially means measurement, and stoichio essentially means the amount. If we can measure the amount of a substance, that is done by stoichiometry. Okay, in order to understand this, we'll begin first with a very common example. For instance, you might have heard a lot of people say that chemistry is very similar to cooking, right? So let's pick an example from cooking and try to understand stoichiometry. Okay, so I'm guessing a lot of you guys might have made a simple plain grilled cheese sandwich, right? So what is the recipe for a grilled cheese sandwich? For making one sandwich, you need 1 slice of cheese and 2 slices of bread, right? So if we use 2 slices of bread and a cheese slice, that would give us 1 cheese sandwich. Now let me ask you a question. How many slices of bread will be required to make 4 grilled cheese sandwiches? If you were to make 4 sandwiches, your answer would be 8 slices of bread, right? How did you come up with this? Very simple. For 1 slice I need 4, so for 1 slice I need 2, for one sandwich I need 2 slices, so for 4 sandwiches I need 8 slices, right? So you basically just did stoichiometry right now. That's exactly how stoichiometry works. So in this case, what is our chemical reaction that is happening? The chemical reaction is we combine 2 slices of bread, 1 slice of cheese to get 1 grilled cheese sandwich. The numbers that you see written in front of these are coefficients that you see in a chemical reaction, and the recipe that you see right here, the recipe is basically our chemical equation. Okay, so based on of this reaction that we are seeing, we can say that 2 slices of bread would give us 1 grilled cheese sandwich. So based off of this, that I can write a conversion factor, which is 2 slices of bread will produce 1 sandwich, right? So now if I know, if I need to go between sandwich and slices of bread, I can start with what's given to me, which is 4 sandwiches. I am looking for 4 sandwich. Now to cancel sandwich, I divide by sandwich, and I'm going from sandwich to slices of bread. What is the conversion factor? 1 sandwich is 2 slices of bread. Sandwich, what cancelled? My answer is in 8 slices of bread. So we got the same math answer as your previous answer that you did in your head, but this is showing you the math that is actually done behind this calculation. Okay, so this is exactly how a chemical reaction works. The coefficients that you see in front is telling you the number of molecules that are needed. So 2 molecules of bread slices will produce 1 molecule of sandwich. Similarly, you could relate the cheese slices with sandwich, which is one slice of cheese will produce 1 sandwich. So if I need to go between sandwich and cheese, I can use this conversion factor. Similarly, you could relate 2 reactants together. So for 2 slices of bread, I need 1 slice of cheese. So you can go and relate any reactant with product, or reactant with reactant, or product with product using a chemical reaction. What is important here? That you should have a completely balanced chemical equation. So your equation should be BALANCED, completely balanced. Okay, so your chemical equation should be balanced, and then the conversion or the coefficients that you see in there would give you your conversion factors. Okay, so now let's see an actual chemistry example. Use that. Consider the following reaction. 2Fe plus 3S gives us Fe2S3, which means for 2 moles of iron will react with 3 moles of sulfur to produce 1 mole of iron sulfide. Okay, this coefficient that you see is the number of moles of that molecules. Only difference is same thing. If in a coefficient you don't see any number written, you can assume that is 1. Okay. So we can use this as a conversion factor that is known as mole to mole ratio or mole to mole factor. This is the ratio of the moles for any 2 substance in a chemical equation. So between Fe and S, you could say 1 mole, 2 mole of Fe is equal to 3 moles of sulfur. Okay, and you can use that conversion factor when needed. Similarly, between Fe and Fe2S3, you could say that 2 moles of Fe is equal to or will produce 1 mole of Fe2S3. Similarly, you could relate sulfur with Fe2S3, which is 3 moles of sulfur are needed to produce 1 mole of iron sulfide. Okay, so basically if I know a certain amount of substance for one of these, any one of these, I know the amount needed, I can figure out the amount of the other by using these conversion factors based on the balanced chemical equation, right? So let's try some question. For instance, how many moles of Fe2O3 can form from 6 moles of oxygen? So what's given to us is 6 moles of oxygen. So moles of oxygen is given to us, and the question is asking to go from moles of oxygen to moles of Fe2O3. Okay, do we have a relationship that relates moles of one to moles of other? Yes. From our chemical reaction, we can say that 3 moles of oxygen will produce 2 moles of Fe2O3. So with what's given, which is 6 moles of oxygen, in order to cancel the moles of oxygen, I divide by moles of oxygen, multiply by moles of Fe2O3. How many moles of oxygen? 3. How many moles of iron oxide? 2. Moles of oxygen got cancelled. The final answer is in moles of Fe2O3, which is finally 4.0 moles, 6.0 moles. Again, how many sig figs we want? Started with 2. We end up with 2 sig figs as well. So that would be our final answer. Now, what is important here? Make sure that your chemical reaction is balanced. And second thing is, you can only do this in moles. When you're going from mole to mole, there is no other relationship that you can work with. You cannot go from grams of one to grams of other in this form. That would not work. You cannot say that 4 grams of iron will produce 2 grams of iron sulfide. That is incorrect. Only this relationship with respect to coefficients is only true if you are working with moles. So only 4 moles of iron will produce 2 moles of iron oxide. So this relationship only holds true when you're working with moles. You cannot do any other conversion. No other unit will work. Okay. So now let's talk about another kind of question that you could get. The previous question we saw was going from moles of one to moles of other. Can we go from grams of one to grams of other? Okay. For instance, let's see here. The question is how many grams of oxygen are needed to produce 45.8 grams of iron oxide in the following reaction. So question, what's given to us is we have 45.8 grams of Fe2O3, that's given to us. The question is asking figure out grams of oxygen. Do we have a direct relationship that can take us from grams of Fe2O3 to grams of oxygen? Do we have a direct relationship? We don't. What is the relationship that we know? We know from moles of iron oxide to moles of oxygen. We don't know how to go from grams to grams. We know from moles to moles. So basically, if we can convert these grams to moles, then we can convert those moles into moles of the other. So always your first aim would be to go from grams to moles. So first thing we'll do is we'll go from grams of iron oxide to moles of iron oxide. Once we have moles of iron oxide, we can go to moles of oxygen using the conversion factor from our reaction, which is mole to mole ratio. And then we can go from moles of oxygen to grams of oxygen using molar mass. So what would be our conversion factors here? We'll go from grams of Fe2O3 to moles of Fe2O3. For this, we need molar mass of Fe2O3. What is the molar mass of Fe2O3? We have Fe2O3. We have 2 atoms of Fe, and each atom of Fe, if you look in your periodic table, each atom of Fe weighs 55.85 grams of Fe. And we have 3 atoms of oxygen. Each atom weighs 16.00 grams of oxygen. So that would be 3 times 16.00. If you plug this into your calculator, that would give you 2 times 55.85 plus 3 times 16.00 will give you 159.7 grams of Fe2O3. So our conversion factor here will be 1 mole of Fe2O3 is equal to 159.7 grams of Fe2O3. That is to go from grams to moles of Fe2O3. Now what is the conversion factor to go from moles of Fe2O3 to moles of oxygen? That is stoichiometric molar ratio right here. 2 moles of Fe2O3 produces or requires 3 moles of oxygen. So that is our conversion factor for this. Now once we have moles of oxygen, we can go from moles of oxygen to gram. How? Again using molar mass of oxygen. So 1 mole of oxygen. Here we'll figure out what is the molar mass of oxygen. Oxygen consists of 2 atoms of oxygen. Each atom from periodic table is 16.00, which means it is 32.00 grams of O2. So that is our molar mass, and those will be our conversion factors. So we begin with, now we have our solution map. Now we can start solving and begin with what's given. What's given to us is 45.8 grams. So I start with 45.8 grams of Fe2O3. Now I want to cancel the grams of Fe2O3. So I divide by grams of Fe2O3 and convert it into moles of Fe2O3 right here. I'm using the first conversion factor. 2 moles of Fe2O3. How many moles? 1 mole. How many grams? 159. Just simply use the numbers from your solution map now. It would be 159.7 grams of Fe2O3. Grams of Fe2O3 got cancelled. Your answer is in moles of Fe2O3. So that is right here. I'm at box number 2. I need to go from box 2 to box 3 using this conversion factor. So I want to cancel moles of Fe2O3. So I divide by mole of Fe2O3, multiply by mole of, again the second side, which is O2. How many moles of O2? 3. How many moles of Fe2O3? 2. Moles of Fe2O3 got cancelled. Your answer. So moles of Fe2O3 and moles of Fe2O3 got cancelled. Our answer is in moles of O2, which means I'm right here at moles of O2 on my solution map. Now we go from moles of O2 to grams of O2. So to do that, I use this conversion factor. To cancel moles of O2, I divide by moles of O2, multiply by grams of O2 from this conversion factor. How many moles of O2? 1. How many grams of O2? 32.00 grams. Moles and moles got cancelled. Our final answer is in grams of O2. So now if you plug this into your calculator, that would give you your final answer in grams of O2. So what do we plug in? We say 45.8 divided by 159.7. Don't forget any of these steps in the middle, okay? Multiply by 3 divided by 2 multiplied by 32.00 would give you 13.7658 grams of O2. How many sig figs did we have in question? 3. How many sig figs do we want? 3. So 1, 2, 3. That would give you 13.8 grams of O2. That would be our final answer for this particular question. Okay, as long as you understand all the relationships, you should be able to convert from grams of one to grams of other. Okay, final answer is 13.8 grams of O2. What is important here? Different conversion factors. So you know that 1 mole of a substance is molar mass in grams of that substance, and you know that X moles of something can be equated to Y moles of something else by using mole to mole ratio from chemical reaction or stoichiometry. Oh, I wrote this extra. Stoichiometry. So you could go from grams of one to moles of other, and then from moles of one to moles of other, and then from moles of the other to grams of the other. So grams of X to moles of X, moles of X to moles of Y, and then from moles of Y to grams of Y. Just remember, when you're going from one compound to other, for instance here I'm going from X to Y, the only way I can do that is in moles. And from grams of one to moles of other, you know you can use that molar mass here. Okay, similarly, if you need to go from number of atoms to number of atoms of other, number of atoms can be converted into moles by using Avogadro's number like we saw previously. Let's try this question. Determine the mass of ammonia that can be produced from 32 grams of nitrogen in the following equation. So this is our reaction that is given to us. Let's first confirm if our reaction is balanced. How many nitrogen? 2. How many nitrogen? 2. How many hydrogen? 6. 3 times 2. How many hydrogen? 3 times 2 is also 6. So reaction is balanced. Now, what is given to us in question? The question gives us 32 grams of nitrogen, and it's asking what is the grams of ammonia. So again, we need to go from grams of one reactant to grams of other. What is the solution map here? We start with grams of 1, which is grams of ammonia. Only way we can go from grams of one to the other is by converting grams to moles. So here first we'll convert grams of ammonia to moles of ammonia. Okay, remember there's no direct relationship from grams of one to grams of other. We have to go to moles. Now from moles of ammonia we can go to moles of, what's given to us is nitrogen. My bad, not ammonia. Given to us is grams of nitrogen. We start with what's given. So grams of nitrogen to moles of nitrogen to moles of ammonia. And then from moles of ammonia, we can go to grams of ammonia. Okay, what are the conversion factors for each? Grams of nitrogen to moles of nitrogen, we need molar mass. What is the molar mass of nitrogen? Nitrogen consists of 2 atoms of nitrogen. So 2 times 1 atom of nitrogen. From periodic table weighs 14.01 grams of nitrogen. That would essentially give you 28.02 grams of nitrogen. So our conversion factor here is 1 mole of nitrogen is 28.02 grams of nitrogen. How about the next conversion factor? The next conversion factor is from moles of one to moles of other. Moles of nitrogen is right here, 2 moles of ammonia. So what is the conversion factor? 1 mole of nitrogen is needed to produce 2 moles of ammonia. Okay, next we have moles of ammonia to grams of ammonia. For this, again we need molar mass. So let's figure out molar mass of ammonia. How many nitrogen atoms? 1 nitrogen atom. So 1 times 14.01 grams of nitrogen. Plus we have 3 atoms of hydrogen, which is 3 times each hydrogen atom is 1.01 grams. So that is a total of 17.04 grams of ammonia. So what is the conversion factor? We know that 1 mole of ammonia here would weigh 17.04 grams of ammonia. So now we have our solution map designed for this particular question along with each conversion factor. So we start with what's given, which is 32 grams of nitrogen. Now you just follow this. I'm here, right here, 32 grams of nitrogen. I want to go from grams to moles. So I divide by grams and multiply by moles. How many grams? 28.02. How many moles? 1. Grams of nitrogen got cancelled. I am right here at moles of nitrogen. Now I need to go from moles of nitrogen to moles of ammonia. To do that, I use this conversion factor. To cancel moles of nitrogen, I divide by moles of nitrogen, multiply by moles of ammonia. Moles of nitrogen is 1, mole of ammonia is 2. Nitrogen got cancelled. Our answer is in moles of ammonia. So now I'm right here. Now I need to go from moles of ammonia to grams of ammonia. So to cancel moles, again I divide by moles of ammonia and multiply by grams of ammonia. Mole of ammonia is 1, grams is 17.04 grams. Mole of ammonia got cancelled. Our final answer is in units, is in grams of ammonia. That's exactly what we were looking for. Now you can plug this into your calculator and figure out what is the final answer in grams. If you plug this into your calculator, you're going to basically plug 32 grams. You're going to basically plug 32 grams divided by 28.02 multiplied by 2 and then multiplied by 17.04. So make sure you're using right parentheses whenever needed. Your final answer would give you, your calculator would give you 38.92077. Okay, now how many sig figs are we looking for? This has 2 sig figs. So we want final answer to have 2 sig figs, which would be 39 grams of ammonia. Because the next following digit is greater than 5, we are going to round it up. So our final answer is 39 grams of ammonia will be produced from this reaction. Okay. Now let's go back to our previous question of making a grilled cheese sandwich. Okay. So we know that for making one sandwich, we need 2 slices of bread and 1 slice of cheese. Now let me ask you a different question. How many cheese sandwiches can be made if we have 20 slices of bread and 4 slices of cheese? So what would be your answer? If you have 20 slices of bread and 4 slices of cheese, how many cheese sandwiches can we actually make? We can only make 4 grilled cheese sandwiches. Why is that? Because we only have cheese that is enough to make 4 grilled cheese sandwiches. We do not have enough cheese to make to use all slices of bread here, right? If that is the case, how would you figure that out? We figured that out by, because in this case, what is limiting our amount of product produced or amount of sandwiches produced? Cheese slices is limiting how much of amount of sandwiches produced here. Cheese slices is controlling or limiting the amount of product produced. So in this case, the reactant that controls the amount of product produced is called a limiting reactant. This is the reactant that is present in lesser amount. It will produce lesser amount of product, and once this reactant is used up, you don't have enough of this reactant to produce or use all of the other reactant. So once I use all 4 cheese slices, I will have the other 12 slices of bread left over, which I will not be able to use to make more grilled cheese sandwiches. Okay, so your limiting reactant is the one that produces lesser amount of product. This is the reactant that gets used up first in a chemical reaction, and this is the reaction that will control how much product is produced from this particular reaction. And how can you solve When you're actually working with a chemical reaction, we use two conversion factors. We'll first figure out how much product is being produced from each reactant. So what do we have? We have 20 bread slices. So we'll use 20 bread slices and we'll figure out how much product or how much sandwiches can we make from here. What is the conversion factor to go from bread slice to sandwich? 2 slices produce 1 sandwich. To cancel slice, I divide by bread slice and multiply by sandwich. 2 bread slices gives 1 sandwich. So bread slice got cancelled, which means 20 slices of bread will produce 10 sandwiches. We do the same thing with the sandwich, the grill slices, the cheese slices that we have. We have 4 cheese slices and we'll figure out how much sandwich can we make from here. So we divide this by cheese slices, multiply by sandwich. We know that 1 cheese sandwich is produced from 1 slice of bread. So cheese slices got cancelled. We know that 4 cheese slices will give us 4 sandwiches. So now you do the same thing for both the products or all the reactants, sorry, not products, all the reactants. You basically figure out how much product is produced from each reactant. Each reactant here is bread slices and cheese slices, and whichever one gives you the least amount of product, that is your limiting reactant. So in this case, our limiting reactant is cheese slices. If I ask what is limiting reactant is cheese slices. And how much of the product can you produce? 4 sandwiches. That is the amount of product that you can produce. You cannot make all 10 sandwiches because we don't have enough cheese slices to make all sandwiches. So this is your yield of the reaction. This is called the theoretical yield of a reaction. Theoretical means in theory, by numbers. Theoretical yield means, in chemistry, yield means production. Theoretical means in theory. This is called the theoretical yield of this reaction. So in theory, if I were to use 4 cheese slices and 20 bread slices, I would end up with 4 cheese sandwiches. Okay, but when you actually do an experiment, you know that there is always a plus minus and error associated with the numbers. So therefore this is called the theoretical yield for a particular reaction. How much product is produced theoretically by using numbers, by using calculation. And when you actually do the experiment, that yield is called the actual yield of the experiment. When you actually do an experiment, the amount that is produced is called the actual yield. What does that mean? For instance, let's say I was making these 4 sandwiches and I'm being my clumsy self, I burnt one of the sandwiches. So even though I started with 4 cheese slices, I ended up with only 3 cheese slices. And that is my actual yield. So my actual yield would be 3, and theoretically I should have ended up making 4, but I only ended up making 3 sandwiches. Okay. Alright. So let's see this in terms of actual chemistry. A limiting reactant in a chemical reaction is the substance that is used up first and that limits the amount of product that can be produced. The other reactant that does not completely react and is left over at the end of the reaction is called the excess reactant, meaning we have excess of it. Some of it will be left after the reaction is done. How would the question look like? The question would look something like this. If 3.00 moles of carbon monoxide and 5.00 moles of hydrogen are the initial reactants, how many moles of methanol can be produced and what is the limiting reactant based on this reaction that is given to us? So what is given to us in question? 3 moles of carbon monoxide, 5 moles of hydrogen. The question is asking how many moles of product will be produced and which is a limiting reactant. Whenever both the reactant amount is given to you, it automatically means this is a question of limiting reactant. So first step for figuring out which is limiting, we are basically going to go from each reactant to product and figure out how much product is being produced. So we will first convert moles of CO to moles of product, which is CH3OH. And what is the conversion factor here? 1 mole of CO produces 1 mole of CH3OH. And we have already confirmed that this reaction is balanced. 1 carbon, 1 carbon, 1 oxygen, 1 oxygen, 2 times 2, 4 hydrogen, 3 plus 1, 4 hydrogen. So now start with moles of carbon monoxide, 3.00 moles of carbon monoxide. To divide moles, I divide by moles of carbon monoxide, multiply by moles of CH3OH. How many? 1:1. So moles got cancelled. I have my final answer as 3.00 moles of CH3OH. We do the exact same thing with the other reactant. We go from moles of hydrogen to moles of CH3OH. And now what is my conversion factor? 2 moles of hydrogen gives 1 mole of CH3OH. So 2 moles hydrogen is 1 mole CH3OH. We start with what's given, which is 5.00 moles of hydrogen. To cancel mole of hydrogen, we divide by mole of hydrogen and multiply by mole of CH3OH. Hydrogen got cancelled. My final answer is in mole of CH3OH. How many moles of hydrogen? 2 moles. I'm getting this number from the stoichiometric coefficient. 1 mole of CH3OH. Your final answer is 2.50 moles of CH3OH. Now, which is producing least amount of CH3OH? This. Hydrogen. So which one is our limiting reactant? Our limiting reactant here is hydrogen. Okay, so that answers this question. The next question is how many moles of methanol is produced? Your answer for that would be 2.50 moles of methanol will be produced. Okay, so that is how you would attempt a question of limiting reactant. This applies whenever both the reactant or however number of reactants are combining together. The amount of each reactant is given to us in the beginning of a reaction. Okay, here's another question. Silicon carbide, which is SiC, is a ceramide carbon material that tolerates extreme temperatures and is used as an abrasive and in brake disc of sports car. How many grams of carbon monoxide are formed from 70.0 grams of silicon oxide and 50.0 grams of carbon? So the question is, this is the reaction given to us. The question is how many grams of CO. So question is asking how many grams of CO are formed from 70.0 grams of SiO2 and 50.0 grams of carbon. So basically 2 reactants are given to us. The question is asking how many grams of one of the products will be produced. So again, this is a question of limiting reactant. So we'll start by first with one of the compounds, which is grams of silicon oxide. We'll go from grams of silicon oxide to moles of silicon oxide. So first go from grams of SiO2 to moles of SiO2. Then we can go from moles of SiO2 to moles of CO. Once we have moles of CO, we can go to grams of CO. And that would be our solution map for going from one of the reactants. Then we do the exact same thing with carbon. We go from grams of carbon to moles of carbon. Moles of carbon to we go to moles of CO, and then from moles of CO we go to grams of CO. We need a molar mass. So you can figure out what is the molar mass of SiO2 now by using periodic table. That would give you this value. Similarly, you'll figure out what is the molar mass of carbon monoxide using the periodic table. So we start with what's given, which is 70.0 grams of SiO2. We want to cancel the grams of SiO2, so I divide by grams of SiO2, multiply by moles of SiO2. Grams and grams got cancelled. Our answer is in moles of SiO2. Now we can go from moles of SiO2 to moles of CO. To cancel moles of SiO, I divide by moles of SiO2, multiply by moles of CO. And the conversion factor is 1 mole of SiO2 gives 2 moles of CO. Again, moles of SiO2 and moles of SiO2 got cancelled here as well. And our final answer is in moles of carbon monoxide. Once I have moles of carbon monoxide, I can go to grams of carbon monoxide by using molar mass. 1 mole of carbon monoxide weighs 28.01 grams of CO. And to cancel the moles of CO, I divide by moles of CO, multiply by grams. Again, moles and moles would cancel. Our final answer is in grams of CO. How many sig figs? We do not care about sig figs of the molar mass. Okay, this again exact, we don't care. This is exact again. Even though it's written here, we don't care because this is an exact number. Only sig fig we care about here is in 70.0, which is 3 sig figs. So our final answer should have 3 sig fig. We'll do the exact same thing with carbon. So grams of carbon, we convert to moles of carbon. From moles, we go to moles of carbon monoxide by cancelling moles of carbon. And then from moles of carbon monoxide, we go to grams of carbon monoxide. And that would give us our final answer is in grams of carbon monoxide. So you can see from here, which one is giving us the smaller amount of product? The answer is SiO2. So in this case, our limiting reactant would be SiO2. Limiting reactant, always remember, is the reactant, one of the reactants. So don't give me the limiting reactant is 65.30 grams of carbon monoxide. That is incorrect. Limiting reactant should be one of the reactant, which is SiO2. And how much of the product is produced? 65.3 grams of CO will be produced. Okay. Alright, moving on, we'll talk about yield. Like I already told you, theoretical yield is the yield that we get from numbers, from calculation. It is the maximum amount of product that can be produced by using a balanced equation. This is based on calculation. Actual yield is the when you actually do the experiment, the amount of product that is actually obtained after the chemical reaction done in lab or the experiment done in lab is the actual yield. And percent yield tells you the ratio between the actual yield and theoretical yield. So you can know how much your yield is in this particular reaction. Is it a good experiment or was it a bad experiment? So percent yield is the ratio of actual to theoretical yield. So formula for percent yield would be actual yield divided by theoretical yield times 100. So if you can figure out what is the theoretical yield for a reaction by using stoichiometry, actual yield will be given to you in question and you can solve for percent yield. For instance, question would look like this. On a space shuttle, LiOH is used to absorb exhaled CO2 from breathing air to form LiHCO3. So LiOH is lithium hydroxide, CO2 lithium hydrogen carbonate. What is the percent yield of the reaction? If 50 grams of LiOH gives 72.8 grams of LiHCO3. So the question is asking what is the percent yield if we have 50 grams of LiOH of this reactant produces 72.8 grams of LiHCO3. So this is the product. So which means this experiment was done and this is the actual yield that was obtained. So question is giving you actual yield. When the experiment was done, 50 grams of LiOH produced 72.8 grams of lithium hydrogen carbonate. Now the question is what is the percent yield? To get percent yield, we know there's only one formula, which is percent yield is actual yield divided by theoretical yield times 100. So we have to solve here. Actual yield is given. We need theoretical yield. If I know theoretical, I can solve for this. So first thing we'll do is solve for theoretical yield. Theoretical yield is based on stoichiometry. So we'll use our same concept, which is what's given to us is grams of LiOH. So we are going to go from grams of LiOH to grams of LiHCO3. And the steps to do that is grams of one will be converted to moles. So moles of LiOH. Then we'll convert moles of LiOH to moles of LiHCO3. Then we can go from moles of LiHCO3 to grams of LiHCO3, lithium hydrogen carbonate. Now we need conversion factor for each one of these. The conversion factor here would be molar mass. What is molar mass of LiOH? Oops, I can't switch my slide. So molar mass, if we solve for LiOH from periodic table, would give you 23.95 grams. So 50 grams of LiOH will convert it into grams of moles of LiOH by using molar mass. So 1 mole divided by grams of LiOH. Grams and grams got cancelled. Our answer is in moles. Now we need to go from moles of LiOH to moles of LiHCO3. From the reaction, we know the conversion factor is 1 mole of LiOH produces 1 mole of LiHCO3. So to cancel moles of LiOH, I divide by moles of LiOH right here, multiply by moles of LiHCO3. 1 mole of this produces 1 mole of that. Mole of LiOH cancelled. I have my answer in moles of lithium hydrogen carbonate. Now that we have moles of this, we need to go to grams. Again, what is the conversion factor? To get the conversion factor, we need to find molar mass of LiHCO3. How would we find that? Again, the formula is LiHCO3. So we have 1 atom of lithium. If you look in your periodic table, 1 atom of lithium weighs 6.94 grams plus 1 atom of hydrogen. Again, from periodic table is that is 1.01 grams of hydrogen. Then we add 1 atom of carbon, which would weigh 12.01 grams, and 3 atoms of oxygen, which is 16.00 grams. The total will come out to 67.96 grams. Again, moles of this and moles of this cancelled. Our final answer is in grams of LiHCO3. This is theoretical yield. Now to solve for the final percent yield, we'll do actual yield, which is given to us in question, divided by theoretical times 100. Actual was given to us as 72.8 divided by theoretical, which we just solved for, times 100. Your final answer would be 51.3%. Again, how many sig figs? This is an exact number. We don't care. Exact, we don't care. Exact, we don't care. Number of sig figs given to us in question is 3. So here the gram should be 3. And then our theoretical yield, number of sig figs given here was 3. Number of sig figs for our answer is 3. So our final answer should also have 3 sig figs. And that is how you can solve